Hey, good morning guys, it's Mr. Roark here. So, sixth graders, we have now moved on, we are done with volume, and what I want to do is take some time really quickly to show you how we write balanced equations and how we solve balanced equations, okay? So what you're going to find out in my class when we start this unit is I'm going to have a scale, okay? And the idea is that scale, we want to always keep it balanced, okay? So in this case, I'm going to draw just a quick scale here, and the example that you guys have in your foldout here is going to look something like this, okay? I'm going to have three triangles, all right, that look something like this, okay? 1, 2, 3, I'm sorry, it's 4. 4. And then over here on this side, I'm going to have one pretty big square, all right, and another triangle, okay? Now right now, obviously I drew this scale to start with, but we're going to imagine for just a minute that this scale is balanced, okay? Right now, there's equal weight happening here, okay? We want to find out, according to, again, this activity here, we want to find out how much does just this square weigh, okay? So the problem with that is this. If I take away anything from this side, or I take anything away from this side, that scale is going to shift one way or the other way, okay? So what I have to do whenever I'm solving balanced equations is this. I have to take away equal amounts from both sides. So we're going to go ahead and call these triangles T. So on this side I have 4T, okay? Let me draw my scale again. Over here, on the other side, I have 1 square, so 1s, and I also have 1t for one triangle. Now, we know right now that is equal, okay? Looks like is it, but it's 1s and 1t, okay? I'm going to do this. To keep my scale balanced, I'm going to take away the triangle that's over here on this side. So I'm going to do minus 1t on this side. The problem was, like I said, if I take this triangle away, it's going to be more heavy this way and it's going to shift, okay? So that scale's not going to be balanced anymore. So what I have to do is I have to take away from over on this side. So over here, I'm going to take away 1t as well, okay? Once I take away from both sides, if I have 4t, 4 triangles, and I take away 1 triangle, well, guess what I'm left with? Now I'm left with, on this side, 3 triangles. And if I have 1 triangle on this side and I take away that triangle, I don't have any triangles anymore. They basically cancel out. So I'm left with 1s, okay? And so what I've just now done is I've solved this balanced equation, and I know that 3 triangles has the same weight as 1 square, okay? If you guys have any questions, you guys can always come find me in room 12. And like I was saying before, we're going to use this scale constantly, okay? I can even show you another really quick example of how this might work, okay? So, give me 1 sec, I'll grab the eraser. And we can solve another one really quickly so you guys have an idea of how this would work in a regular scenario, okay? So, I'm going to erase this. I'm actually working on the backboard right now because I have some stuff for you guys written on the front board today, okay? So let's go ahead and draw our scale again. Here's our balanced scale, all right? I'm going to draw another scale here, and I'm going to draw another one down here, okay? This is going to be a process that we're going to solve step by step by step, okay? So we're going to say this scale is balanced. I'm going to say over here on this side is the number, let's say 27, okay? Over here on this side, we're going to put another problem. We're going to put 3x, all right, plus 3, okay? So we've got 3x plus 3 is the same weight, it's equal to 27. And so to solve this problem, I have to find like terms, okay? So that 3 and that 27 are like terms because there's no x associated with this one. So the first thing I want to do is get rid of, I want to try to get this x by itself because I need to find out what is the value of x. I'm going to subtract 3 from this side, but if I do that, it's going to be unbalanced again. My scale is going to become unbalanced. So I have to subtract 3 from this side. What I'm left with then is 3x equals 27 minus 3 which is 24. Now, here's the thing. Some of you guys are probably already seeing 3x equals 24, or 3 times something equals 24. And mentally, you guys already know what the problem is. We need to solve this anyways. This means 3 times something equals 24. The opposite of addition in this case is subtraction. The opposite of multiplication is division. So now I'm going to divide by 3 here, and I'm going to keep it balanced by dividing by 3 over here. What I'm left with is 1x over on this side, because we know that if I have 3 and I divide 3, 3 goes into 3 one time. And over here, I've got 24 divided by 3. 24 divided by 3 will give me an answer of 8. Okay? So I know that 1x is equal to 8. And I can actually take this number, if I want to check my answer, and I can plug it into that spot and see if it works. Okay, let's find out. Does 3 times 8 plus 3 equal 27? I think it does. All right. Guys, like I said, if you have any questions, you can come find me in room 12. I'm always happy to help you guys and understand this. All right? Thanks a lot. See ya.